All right, so we're going to continue in chapter 14, section 2. Again, this is 13.2 in your math lab, so be aware of that. And we're continuing to talk about transformations. Up to this point in section 1, we talked about rotations, we talked about translations, and then we talked about tessellations and how we can use rotations or translations to make those. And so today we're going to continue and talk about another type of isometry, which is a reflection or a flip. And one common example of this would be looking at yourself in a mirror, right? You go look in the mirror every morning when you get up and you see yourself. You see a reflection of yourself, okay? Now, the distance you are from your mirror is how far you appear in your reflection. So if you are, let's say, 2 feet from your mirror when you look at it, well, in your reflection, you appear to be 2 feet from that mirror, okay? And so that is a very basic example of where we see reflections in our everyday lives. Now, a reflection from a geometric standpoint is when we take a figure and flip it across a line. So reflection in line L is a transformation of a plane that pairs each point P of the plane to a point P prime in such a way that L is a perpendicular bisector of P prime. Okay, so the line between P and P prime is a perpendicular bisector, L is a perpendicular bisector of that segment. And so we're going to make that make a lot more sense in just a minute as we look at some examples. So, how do we go about making a reflection? Again, a lot of this stuff as a geometry teacher, I think is really interesting to do with students. Let them get hands-on with some of this because this is very active. Again, if we were doing this in a traditional class where I'm in the classroom with you, I'm probably going to have you do a lot of this stuff by hand. So one easy way to do a reflection is to take a piece of paper and fold it in half. On one side of that piece of paper, draw some picture. Here you see half of a Christmas tree. Okay? And then when you fold that paper in half, trace over that same image, and then when you open it back up, you have your full tree, just like you see in figure B here on the screen. So you can fold it in half and then draw the other half like that. Now, if you have the technology in your classroom or the tools to do this, there's a device called a mirror, like here in part C. And you can actually draw a reflection using this mirror. And without having one to show you, it's kind of hard to explain. But essentially what you do is you put that on your line of reflection, and then you trace what would be on the other side, and you're able to do your reflection. Again, hard to explain without showing it to you, without actually having you do this yourself. But as you are teaching upper elementary school or even into geometry, if you were to teach at the high school level, this is something that you can have your students do, hands-on activities. I have a whole book about doing reflections and rotations and all that I used to use in my geometry class when I taught in high school. And so don't hesitate to find resources as you become a teacher and use some of these hands-on activities. I think they're really, really great. Again, in an online format, it's kind of hard to do that and show you how that would work, but that is something hopefully that you can do. All right, so how could we do it with tracing paper? This actually is pretty easy to do as well. You start out by drawing a figure, and you draw a reference line. So this line is vertical line is your reference line, your reflecting line. And you're going to put a point on that line as a reference point. And so what you would do is on your trace paper, you would trace your original triangle, and then you would flip your trace paper over, and you would put this point X back on top of itself and the reflecting line back on top of itself, and you would draw that figure again. And so what you would have is this as your reflected image. Now, if this is a true reflection, the line between point A and point A prime, so this line, should be perpendicular to this reference line, or this reflecting line. And just a minute ago, we said that reflecting line should be a perpendicular bisector. It should be perpendicular, and it should also split that line from A to A prime, should split that segment in half, okay? And so as we are talking about doing reflections, again, I'm not going to ask you to draw any of these or to do this on a test, but I think it is good that you have an idea about how this reflection works, because once you get that good understanding, well, then it's a lot easier to work some problems where you would have to use reflections. So let's look at this example. We want to find the image of triangle ABC under reflection in line M. All right, so let's think about this. We want our new triangle, we're going to call it A prime, B prime, C prime. That's going to be the one that we're going to draw. We want it to look just like the original triangle ABC, but we want it reflected across this line M. Now, since point C is on the line, then point C prime is also going to be on the line. And that's one thing we know for sure. We also know that if you were to take, let's start with point A, and you were to draw a perpendicular line to that reflecting line, and then continue it across the same length, you would find out that A prime needs to be at this point. And then you can do the same thing with B. So if you were to draw a perpendicular line to the reflecting line and then extend that out again, you would find out that point B prime should be here. And so our new triangle, once it's been reflected, should look something like this. And hopefully you can see that if you kept point C where it is and you just flipped it over, you would have the same image. And so you do see that show up there in blue over mine, A prime, B prime, C prime. If you have any questions about the reflection, let me know. We'll continue talking about reflections a little bit in our next video.